Welcome and hello. This is a video exercise in HEC ResSim, and in this exercise, we're going to be dealing with yield analysis. This is a way to determine the firm yield of a reservoir over the course of a simulation. All right, so let's go ahead and get started. What I have on the screen here is ResSim, and I'm in the watershed setup module. I'm going to start by going File, New Watershed. We're going to build the watershed, the network, run the simulation, and see some results. All right, so I'm going to name my watershed Video 34. You can name your watershed whatever you want if you're following along. All right, so selecting the directory, I want to save the watershed directory to. Select the units and then the time zone. Then go ahead and click Apply and OK. All right, so our watershed's been created. It says the name of it up here in the title. Next, I'm going to select the stream alignment tool and then zoom in a little bit. I'm going to hold down the control key and then single left click to start the stream alignment on the upstream end, and then continuing to hold down control. Just go ahead and continue clicking with the left mouse button, and then just before your last click, let go of control, and it'll ask you to give that stream a name. All right. Next, what I want to do is select the computation point. So this tool down here, the black dot in the bottom, and then hold down Control on my stream alignment and click. I'll just call it CP1. And then I'm going to create a reservoir. So I'll select the reservoir tool, hold down Control, single left click on the upstream end of the reservoir pool, and then let go of Control, another click at the dam face. I'll just call this reservoir 1. And let's just add one computation point at the bottom of the reach or near the bottom of the stream alignment for good measure. We'll call that CP4. All right, watershed configuration editor. This is how you create a configuration. Configuration new, give the configuration a name, select the time step, okay, apply, okay. All right, that's good. I'm going to file, save watershed. Next, I'm going to select the reservoir network option from the module dropdown. And the first thing here is to create a network. So we'll go network new. Then for the name, I'll just call it network. This is going to be our only network for the exercise. So whatever you call it, it's probably not too important. And then select configuration 1 that we just saved for the configuration, and then click new. All right, to connect that network, let's go ahead and select the reach tool and then hold down control on the upstream end, let go of control, and then click the next downstream junction to connect the two. And I'm just going to use their default name, their suggested name here of the junctions. All right, I'm going to go ahead and save. Next, let's go ahead and assign an inflow to this upstream junction CP1. And then what will happen in the simulation is that that junction will receive inflow. It'll get routed down to the reservoir, and the reservoir will release that water based on its controlling logic. All right, so edit and then junctions. Let's go ahead and select CP1, and then the local flow tab is where we would just type in inflow at CP1, factor of 1, apply. Okay, it's got a little circle around it to indicate it has local flow at that junction. Next, let's go ahead and actually create that inflow. I'm going to go to Tools, HEC DSS View. Now I want to create a DSS file first. I'll just go File New. I'll call this time series data, and it is saved now. Here's the file represented by this little tab. I'm going to go Data Entry, Manual Time Series. I'm going to type in some generic data here. Project, the location within that project. This is flow, represented by the inflow, and this will be for CP1. The time interval for E is actually going to be 1 day. So there's that. And then this is going to be a 1 year long simulation. So I'll just say 1 January 2023, 2400 hours, and then CFS. And then instantaneous value is fine. It'll probably convert to period average anyway. All right, now all we have to do is go ahead and type in those values. They're on my clipboard now. So I'm just going to right click, paste them in. You can, copy from Excel, paste them in like I just did here, or you can type them in. I'm going to click save, and then I'll show you very briefly what those inflows look like. Here they are on a plot here. So it starts at about 4,000 CFS, peaks at about 9,000, and then drops down. Again, this is over the course of 2023, and it is daily inflow data. All right, so I'm going to close that. We can close DSS view. Time to go ahead and make some edits to our reservoir. We will assign that inflow we just created to CP1 in just a bit when we get to our alternative editor. All right, so let's go ahead and select the reservoir tool, right click on the reservoir. First off, let's go ahead and define the reservoir geometry, which is the pool geometry. It's called the reservoir pool. I'm going to right click and then paste. I have this data saved on my clipboard. The total storage is 100,000 acre feet. You can see here at the top elevation of 1,500. So just keep that in mind, 100,000. And then the top of dam elevation, again, is 1,500. I'm just going to make up a top of dam length. And then what I want to do is add some outlet structures so that we can release the water without overtopping. Okay, I added a controlled outlet. Now I'm going to paste in the data. And to be safe, I'll just say there's 10 outlets. So the outlet capacity will not affect the simulation. There's plenty of outlet capacity. All right, next over in the operations tab, let's go operations new. This is how we create an operation set. And then I'll click OK. It gives me 3 zones for flood control, conservation, and inactive. By default, the conservation zone is designated as the guide curve elevation. So let's go ahead and type in some numbers. 1,500 is at the top of the dam, so that's the top of the flood control zone. Conservation we're going to say is 1,450 for this exercise, and apply. And then the inactive zone, at the top of the inactive zone will be 1,400, and apply. Okay, I do need to add a rule. I'm going to call it min yield analysis rule, and that'll be releasing from the controlled outlet. It'll be a release function of rule, and we'll just say it's a constant by date of something small and simple like 100 CFS. And then minimum here, and that looks good. I'm going to apply to all zones, so the flood control zone as well, and that looks good. I'm going to click apply. Okay. Alternative, edit. This is where we create the alternative now. So let's go alternative, new. I'm just going to call this base case. So I'll just, base is fine. And then we'll use a 1 hour time step. Now we also want to select yield analysis. So it's not just the standard alternative. This is actually ResSim conducting its own specific simulation mode here based on yield analysis. So we will be going up to this yield analysis tab in just a moment. But before then, let's do the other parts. Operations is operation set 1. The look back data is sort of the starting data. So let's go ahead and give it an elevation of 1450 because that's the guide curve elevation. That's a good place to start, I think. 2000 CFS. And then the time series itself, I'll select this DSS path button. Navigate to that time series data.dss file, click open, select the record, and then click the set path name button and click OK. So that reference to the time series that we created earlier has now been assigned to CP1 for our alternative. All right, as promised, we'll select this yield analysis. I'm going to select reservoir yield so it can use the whole reservoir, not just a specific water account fraction of the reservoir. Water supply, that's fine. I should be seeing my rule in here, so I'm not sure where that went. Hold on a second. Save. Okay. I'm going to right click. Where did my rule go? So this rule should be there. Go back to my alternative editor. Oh, there it is. Okay. Well, I click select and then that rule data populated down below. Got to scroll down, I guess. Now what we have to specify is the tolerance for the flow and then the tolerance for the storage. For the flow, I'm going to actually set it to 1. And then for the storage, 1,000 acre feet is fine. So 1 CFS, 1,000 acre feet. Let's see what happens here. The lower limit of the conservation pool is set to inactive. So that's what I want. It's going to take the water all the way down to basically the inactive zone, which should occur right at December 31st at the end of the year if the reservoir is large enough based on these inflows. All right, so everything else looks good. I think we're ready to go ahead and give this first alternative a shot and see how it goes. So I'm going to save the alternative. I'm going to go network save and then hit up the simulation module. Let's create a simulation. I'm just going to call it Sim1. Remember, this is for the year 2023. So I'm going to start the simulation on the second day of the year, and then the look back will start on the first day of the year, and it is going to end on the last day of the year So 31 December. And again, I'm going to put the hours to 2,400 hours for all three. I'll select the alternative down here and then click OK. All right, so here's the image of the network in the main display and the simulation tree on the right. I think we're ready to run. I'm just going to go ahead and click compute, and it's doing its iterations right now. You can see in the output, there's 10 iterations, 11 iterations over the course of 6 seconds. So I'm not too interested in reading this data here, but what I do want to look at is the report data, storage yield analysis, and then output summary report. And what we see here is it starts at 100 on the first trial, 200, 400, 800. Finally, it fails for flow on 1600. So it backs off, failed again, backs off, failed again. Finally, it converged at 862. So this is the flow rate. I'm for the firm yield for 2023 based on all of our input data. I'm curious to look at this plot though. Okay, the one problem with this plot that I realize is it's not using any of the flood control zone as storage to maximize that firm yield. So what I'm going to do for my first trial off of this alternative is change the guide curve to be the flood control zone at 1,500 feet of elevation. Let's run the simulation again and then get a different number for that firm yield. So what I'm going to do is I'll just create a trial. I'll say new trial. And then what I'm going to do here is I'll say it's still going to be 100,000. Okay. But that is something I will probably change in a later trial, and then click OK. And so that's a copy of the alternative. I'm going to go edit run reservoirs. Then here I'm going to just make a few changes. I'm going to go operations, set guide curve. So now the guide curve is at the top, 1500. And then I need to reset the flow to 100 because it makes it easier to read the report, which we'll take a look at as well. And yeah, let's go ahead and see what that looks like. It should be more than it was the first time. All right, let's go ahead and click compute and see what happens. It's going through the iterations right now. That's 10, 12 iterations. So 1418.75 is what it looks like it converged on for that firm yield. So if I plot the results, here we have on top the water surface elevation. It starts at 1450, but you can see the guide curve elevation is dictating, and then ultimately we have a lot of overflow because the outflow matches the inflow. On the bottom plot here is the inflow, and then in the green on the bottom is the outflow. So it's only really honoring that firm yield for the first month or 3 weeks or so, as well as the second half of the year. And what's interesting here, if you look down the top plot and the green line here, is that the the water surface elevation doesn't end the year at 1400, which is the minimum active zone, the top of the inactive zone, but rather it bottoms out here at early December, it looks like. So that's probably not what we want. And we know the reservoir is undersized because of all the overflow happening earlier in the year. But we would expect that the minimum value would occur on December 31st, not a month earlier. Okay, we can take a look at the table itself. So if I go reports, storage yield analysis, and then this is trial one. The first iteration, it used 100 CFS, and then 200, and then 400, and then 800. You can see in this column here. And then once it hit 1600, it failed. So it backed down and split the difference. Then it took 1200, it passed. Then 1400, it passed. 1500 failed. So it backed down to 1450 and finally converged on 1418.75 as a flow that passed both the storage convergence and our tolerance and the flow tolerance. And we can see that the minimum date is right here at December 3rd. So we want this to be December 31st, not December 3rd. All right, so this is a quick little glance at what happened during the iteration, which is a nice summary table. Let's go ahead and increase the size of the reservoir and see what happens. So I'm going to just right click new trial, and it's just going to be 200K. So I'm going to double the size of the reservoir pool and right click, edit. So now I'm going to go reservoirs, and a few things that need to happen is, of course, the reservoir pool needs to increase. Control V to paste in my numbers. So now we have 200,000 acre feet as the total storage. Everything else here stays the same, but over in the operations tab, I want to reset the initial release to be 100 again, just to make it easier to read the report. And I like doing it that way. Okay. All right. And then let's go ahead and compute. So it's running the iterations now. There's 10 iterations, 17 iterations, 1741. So much more flow. Let's go ahead and look at the plot from the previous one and this one. Okay, in red here is the 200,000 acre foot trial 2. And we can see that there's more volume because it takes longer to fill up using the same inflow time series. And we can tell that it still bottoms out here at early December, December 3rd, probably. Yeah. In the bottom plot, we can see that it's releasing the same as the inflow from probably during April, May, and some part of June. So that's probably not good as well. Let's go ahead and look at the numbers. So I'm going to look at the report here. This is for trial 2. And we see it converges down to 1,741 CFS. So this is much more than it was at 1419. We have more than 300 CFS more firm yield by doubling the size of the reservoir. But I bet we could actually get a higher number here if we increase the reservoir size even more based on that overtopping we saw in the plot. All right, so let's do that. Let's go ahead and create a new trial. Instead of 200,000, let's go ahead and go 400,000 acre feet of storage in the reservoir. I'm going to go right click and edit this trial, reservoirs. Okay, I'm going to paste in the larger numbers here. Now we're up to 400,000 acre feet of total storage in the reservoir. So I'll click apply, and then in the operations tab, I want to reset that minimum flow value to 100. That's just how I like to do it. Okay, and let's go ahead and compute. So it's running through the iterations now. So it's past 10 iterations. It's past 20 iterations. Okay, this might not converge. Okay, so it didn't converge, and that's not a problem. That's bound to happen eventually. Now it's up to us as the modelers to go into the yield analysis tab and maybe increase the number of iterations. I found that that's not the best way to go. What I'm going to do is stick with 1 CFS as the tolerance on flow, but I'm going to increase the volume. Let's give it 10,000 CFS instead as the tolerance for storage. So I'll click save here. And then I want to actually go to reset this value. Okay, so it looks like it was trying to converge at 2160, and that might be our number, but let's go ahead and let the ResSim converge first. So let's run the simulation again here. Okay, it looks like 2150 is what it's giving me. So again, we doubled the size of the reservoir. We increased our firm yield by like another 400 CFS. Let's go ahead and look at the plot and compare it with the previous 2 plots. Okay, so now in blue, we have no overtopping. You can see it's just like a constant blue line across for the entire year. And then in the top plot, we see the water surface elevation. It is approaching the very top. It comes dangerously close, but doesn't touch. And it looks like the final storage is pretty close to the bottom of the reservoir pool. And the reason why it's not the same is probably because I increased that storage, the storage tolerance. Okay, off camera, I went ahead and created one more reservoir that's double the size again. Now it's 800,000 acre feet. Okay, so I'm going to go ahead and run that 800,000 acre foot trial number 4. It looks like it converged again on 2,150. So we'll go ahead and click close. Let's go ahead and take a look at the plot for just 400,000 acre feet and 800,000 acre feet in the reservoir pool total storage. And it looks like they are identical, which is actually not too surprising because we would expect that to be the case. There's no overtopping in either situation. It's the same inflow, it's the same starting initial conditions and so on to the reservoir. What I have on the screen here is just a quick summary of our results. We have the reservoir total storage in acre feet with our 4 different trials, 1, 2, 3, and 4. And then the firm yield that we calculated, which increased with the reservoir storage. But of course, after a certain size of reservoir, we didn't get any additional firm yield. And of course, this is just 1 year's worth of data. There could be different simulation parameters used to modify the numbers. For instance, this may actually be 2160 or 2160 point something else. And of course, 1 year of data isn't worth a lick. You need to have lots more data than that to be reliably confident in your answer. This was an exercise in HEC ResSim, specifically the yield analysis alternative method to determining firm yield in a reservoir simulation across a certain duration of time.